The morning of August 2nd, 2025, began like any other across Russia's far eastern coast. The sky was a pale, washed-out blue over the Kamchatka Peninsula. Fishing boats chugged out of quiet harbors, their crews focused on the day's catch. But, deep beneath the cold waters of the Pacific Ocean, the Earth had other plans. Tectonic plates, colossal slabs of our planet's crust, had been grinding against each other for centuries, building up an incredible amount of stress. At precisely 7:42 a.m. local time, that stress was released. The seabed violently ruptured. It unleashed a monstrous earthquake, a magnitude 9.1 tremor that shook the very foundations of the world. The ground did not just tremble, it liquefied, swaying like a stormy sea for several terrifying minutes. On land, the devastation was immediate and absolute. Buildings constructed to withstand harsh winters simply disintegrated, collapsing into clouds of dust and debris. Roads buckled and split open, creating impassable chasms where smooth asphalt had been moments before. The shaking was so intense that it was felt thousands of miles away, a grim reminder of the planet's restless power. But the earthquake was only the beginning of the horror. The immense displacement of the seafloor had generated something far more insidious. A colossal wall of water, a tsunami, was now racing towards the coastline at the speed of a jetliner, silent and unstoppable. The tsunami warning systems, though advanced, could offer little more than a few minutes of notice. The waves struck with unimaginable force, surging inland for miles. They erased entire towns from the map, leaving behind a wasteland of splintered wood, twisted metal, and saltwater-soaked earth. The disaster in Russia was a catastrophe of staggering proportions, a stark display of nature's raw and untamable energy. It served as a powerful alert, a single violent event along a much larger and more dangerous feature of our planet. The quake was just one note in a symphony of destruction that could, in theory, play out on a global scale. It forces us to ask a terrifying question. What if this was not an isolated event? What if this was the prelude to something far, far worse? The epicenter of this devastating quake was located directly on one of the most volatile geological structures on Earth. It is a place known to scientists and disaster planners by a fittingly dramatic name, the Ring of Fire. So, what exactly is this Ring of Fire? It is not a literal ring made of flames, but it might as well be. Imagine a colossal horseshoe shape stretching for an astonishing 25,000 miles or 40,000 kilometers around the rim of the Pacific Ocean. This massive arc runs up the western coast of South and North America, sweeps across the Aleutian Islands of Alaska, dips down through Japan, the Philippines, and Indonesia, and continues all the way to New Zealand. It is the planet's most active and dangerous geological feature. It is a place where the Earth's crust is constantly being born and destroyed, a battleground of immense subterranean forces that shape the world we live on. This fiery belt is home to approximately 75% of the world's volcanoes. More than 450 volcanoes, both active and dormant, are strung along this arc like explosive jewels on a deadly necklace. These are not small, gentle hills. They are some of the most powerful and iconic mountains on the planet. From Mount St. Helens in the United States to Mount Fuji in Japan and Mount Pinatubo in the Philippines. The Ring of Fire is not just about volcanoes either. It is also the epicenter for about 90% of the world's earthquakes, including most of the largest and most destructive tremors ever recorded. The constant seismic activity is a direct result of the same forces that create the volcanoes. The reason for all this activity lies in the theory of plate tectonics. The Earth's outer shell is broken into a series of massive, rigid plates that are constantly moving, floating on the semi-molten mantle beneath. The Ring of Fire marks the boundaries where several of these major plates collide, slide past, or are forced under one another. For example, the huge Pacific Plate is being pushed underneath the surrounding continental plates in a process called subduction. As the oceanic plate dives deeper into the Earth, it melts under intense heat and pressure. This molten rock, known as magma, is less dense than the surrounding rock, so it rises to the surface, eventually erupting to form the volcanoes that define the ring. This process of subduction is not smooth. The plates lock together for long periods, building up immense strain. When the strain becomes too great, the rocks suddenly fracture and slip, releasing a burst of energy that we experience as an earthquake. This is why the same regions that host powerful volcanoes are also plagued by frequent and violent earthquakes. The Ring of Fire is therefore a direct and dramatic expression of our planet's dynamic and ever-changing nature. It is a constant reminder that the ground beneath our feet is not as solid or as stable as we might like to believe, and that its immense power can be unleashed at any moment. The recent disaster in Russia, with its powerful earthquake, naturally leads to a pressing question. Can a massive earthquake trigger a volcanic eruption? For a long time, the scientific community was divided on this topic. It seemed plausible, but direct evidence was hard to come by. An earthquake sends powerful seismic waves vibrating through the Earth's crust for thousands of miles. It seems logical that these intense vibrations could disturb a nearby magma chamber, a subterranean reservoir of molten rock that feeds a volcano. Think of it like vigorously shaking a bottle of fizzy drink. The shaking agitates the dissolved gas, increasing the pressure inside until the cap can no longer hold it in. Recent scientific studies are beginning to confirm this connection, moving it from the realm of speculation to observed fact. Researchers have analyzed historical data and found compelling correlations between large earthquakes and subsequent volcanic activity. For instance, studies have shown that volcanic eruptions can become more frequent in the months and even years following a major seismic event in the same region. The energy released by a magnitude 8 or 9 earthquake is colossal, and it doesn't just shake the surface. It can change the stress patterns in the crust over vast areas, squeezing or stretching the rock surrounding a magma chamber. This change in pressure can be the final nudge a volcano needs to erupt. The mechanism is thought to work in a few different ways. The seismic waves themselves can cause bubbles of gas within the magma to form and expand rapidly, a process called bubble nucleation. This makes the magma more buoyant and foamy, helping it rise faster towards the surface. In other cases, the shaking can create new fractures in the rock above the magma chamber, providing an easier pathway for the magma to escape. It might also cause the walls of the magma chamber itself to fail, forcing the molten rock out like toothpaste from a squeezed tube. The connection is strongest for volcanoes that are already in a critical state, primed and ready to blow. However, it is crucial to understand that this is not a simple cause and effect relationship. An earthquake does not guarantee a volcanic eruption. The volcano must already be loaded and ready to go. The distance and magnitude of the earthquake also matter significantly. A powerful quake hundreds of miles away is more likely to have an effect than a small one nearby. So, while the idea of a single great quake setting off a chain reaction of volcanic eruptions along the Ring of Fire is a terrifying thought, the science suggests the connection is more localized and nuanced. A quake in Chile is highly unlikely to wake up a volcano in Japan, but it might just stir one next door. To truly understand the danger, we need to look at what happens inside a volcano before it erupts. A volcanic eruption is not simply a mountain spewing out lava. It is a complex and violent process driven by immense pressure from deep within the earth. The story begins miles below the surface, in the magma chamber. This is a vast cavern filled with molten rock, a searingly hot slurry of melted minerals, crystals, and most importantly, dissolved gases. These gases, primarily water vapor, carbon dioxide, and sulfur dioxide, are trapped within the magma by the incredible pressure of the overlying rock. This mixture of magma and gas is the engine of the eruption. As more magma from deeper in the mantle feeds into the chamber, the pressure begins to build. At the same time, the magma may begin to cool slightly, causing crystals to form. This process forces the dissolved gases out of the liquid magma, creating bubbles. These bubbles are the key to an explosive eruption. Just as carbon dioxide bubbles are released when you open a can of soda, volcanic gases come out of solution as the magma moves towards the surface and the pressure drops. This is a runaway process. As the magma rises, more gas comes out, which makes the magma lighter and helps it rise even faster. The eruption happens when the pressure of these expanding gas bubbles becomes too great for the volcano's plumbing system to contain. The cap of rock sealing the volcano's vent eventually fails, and the contents of the magma chamber are violently expelled. The force is unimaginable. The gases expand explosively, shattering the magma into tiny fragments of rock, glass, and ash, which are blasted high into the atmosphere at supersonic speeds. This is what creates the towering ash clouds that can travel around the world. The eruption is essentially a massive geological explosion, powered by the same principles that make a shaken soda can spray everywhere. The type of eruption depends heavily on the magma's composition. If the magma is thin and runny with very little gas, it will tend to ooze out as gentle lava flows, like those seen in Hawaii. However, the volcanoes along the Ring of Fire are often filled with thick, sticky magma that is rich in silica and loaded with gas. This viscous magma traps the gas bubbles, allowing immense pressure to build up. When these volcanoes finally go, they do so with extreme violence, producing the most dangerous phenomena: catastrophic pyroclastic flows, towering ash columns, and widespread devastation. This is the type of eruption we fear most. Now let us engage in a thought experiment. It is a scenario that keeps geologists and volcanologists awake at night, even as they stress its near impossibility. What if the unthinkable happened? What if a truly colossal, unprecedented earthquake, a magnitude 10 or greater, struck somewhere along the Pacific plate? Imagine a rupture not just for a few hundred miles, but for thousands of miles, unleashing energy that dwarfs anything humanity has ever recorded. What if this megaquake was powerful enough to disturb not just one or two nearby volcanoes, but to simultaneously jolt hundreds of them all along the 25,000-mile Ring of Fire? The scenario begins. Within hours of the initial cataclysmic tremor, the sleeping giants begin to stir. On the west coast of the Americas, from Chile's Andes to the Cascade Range in the United States and Canada, volcanoes that have been dormant for centuries roar to life. Plumes of black ash punch through the clouds, turning day into an eerie twilight. In Japan, the iconic Mount Fuji, long a symbol of peace, erupts with a violence not seen in 300 years. The same happens across the Philippines, Indonesia, and New Zealand. It is not a single eruption, but a global chorus of fire and fury, a simultaneous planet-altering event. The sky across the entire Pacific Rim would darken. A constant rain of gritty gray ash would begin to fall, blanketing cities and countryside alike. The air would become thick with the smell of sulfur, acrid and choking. The constant low roar of distant and not-so-distant eruptions would become the new soundtrack of life, punctuated by the ground-shaking booms of the largest explosions. Communications would be severed as satellites are damaged by ash and ground stations are buried. Air travel would cease globally, not just in the Pacific. The world as we know it would grind to a halt, its inhabitants trapped under a sky of fire and ash. This is the nightmare scenario, the simultaneous awakening of the Ring of Fire. It is a concept straight out of a disaster movie, yet it is founded on the very real geology that governs our planet. The sheer scale of such an event is difficult to comprehend. It would not be a local or even a regional disaster. It would be a global catastrophe of the highest order. The immediate effects would be devastating, but they would be just the opening act for a much longer and more grueling period of global change that would challenge the survival of civilization itself. The first days would be about shock and survival, but the years that followed would be about enduring a new, harsher world. In our hypothetical scenario, the immediate consequences for anyone living near the erupting volcanoes would be, well, absolutely apocalyptic. The most immediate danger would be the pyroclastic flows. These are not slow-moving lava flows. They are superheated, fast-moving avalanches of gas, ash, and rock fragments that can exceed temperatures of 1,000 degrees Celsius, about 1,800 degrees Fahrenheit. They race down the slopes of a volcano at hundreds of miles per hour, incinerating everything in their path. Entire cities, like the ancient Roman city of Pompeii, could be buried and sterilized in a matter of minutes. There is no surviving a pyroclastic flow. Simultaneously, the eruptions would trigger a cascade of other related disasters. The sheer weight of the falling ash would cause buildings to collapse, especially when mixed with rain, turning into a heavy, concrete-like slurry. This wet ash would also create another deadly threat, lahars. These are volcanic mud flows with the consistency of wet cement that can thunder down river valleys at high speed, sweeping away bridges, roads, and entire communities. Eruptions occurring on or near the coast or causing underwater landslides would generate a series of massive tsunamis, battering coastlines around the Pacific Basin with waves far larger than the one that struck Russia in our opening story. The air itself would become a weapon. The volcanic ash, composed of tiny, sharp particles of rock and glass, would be catastrophic for human health. Breathing it in would be like inhaling microscopic shards of glass, leading to severe respiratory illnesses like silicosis. Water supplies would be contaminated, becoming acidic and poisoned with toxic minerals, rendering them undrinkable. Agricultural land for hundreds of miles around each volcano would be buried under a thick, sterile blanket of ash, destroying crops and poisoning the soil for years to come. The immediate zone of destruction around each of the 450 erupting volcanoes would be absolute. The scale of the human tragedy would be, well, truly incomprehensible. Hundreds of millions of people live in the shadow of the Ring of Fire's volcanoes, in major cities like Tokyo, Manila, Seattle, and Santiago. The simultaneous eruption would mean that there would be nowhere to evacuate to. Each neighboring region would be facing its own identical crisis. Governments would collapse under the strain. Emergency services would be overwhelmed or destroyed. It would be a fight for individual survival in a world where the ground itself had turned against its inhabitants, unleashing a multi-pronged attack of fire, ash, mud, and water. The local devastation, however horrific, would only be the beginning. The true global impact of the Ring of Fire's simultaneous eruption would come from what it throws into the sky. A single large volcanic eruption can inject millions of tons of ash and gas into the stratosphere, the upper layer of the atmosphere. Now just imagine multiplying that by hundreds. The combined eruptions would blast an enormous planet-shrouding cloud of volcanic material into the sky. The fine ash particles, and more importantly, sulfur dioxide gas would spread from the Pacific to encircle the entire globe in a matter of weeks. This is where the long-term catastrophe begins. In the stratosphere, the sulfur dioxide gas reacts with water vapor to form tiny droplets of sulfuric acid, creating a persistent hazy veil. This veil acts like a mirror, reflecting incoming sunlight back into space before it can reach and warm the Earth's surface. The result would be a dramatic and rapid period of global cooling, often referred to as a volcanic winter. Global average temperatures could plummet by several degrees, and the effect would last for years, until the aerosol particles finally fall out of the stratosphere. This cooling would be uneven, with some regions experiencing much more severe temperature drops than others. The consequences of such a sudden global cooling would be catastrophic for life on Earth. The most immediate impact would be on agriculture. Growing seasons would be shortened or eliminated entirely. Unseasonable frosts and freezes could kill crops in the middle of summer. Monsoons and rainfall patterns, on which billions of people depend for food and water, would be disrupted, leading to widespread and prolonged droughts in some areas and devastating floods in others. The world's food supply chains, already fragile, would completely collapse. The breadbaskets of the world, from the American Midwest to the plains of Ukraine, would fail. This would inevitably lead to global famine on a scale never before witnessed in human history. With crops failing year after year, mass starvation would become a certainty. The sudden environmental shock would also devastate natural ecosystems. Forests would die off, marine life would suffer as the oceans cool and become more acidic, and countless species would be driven to extinction. Society would be torn apart by the struggle for dwindling resources. It would be a fight for survival not just against the elements, but against each other. The volcanic winter would be a long, dark, and cold period for humanity. This terrifying scenario of a volcanic winter is not just theoretical speculation. We have seen glimpses of it in our own history. We have small-scale examples that demonstrate the immense power of a single large eruption. The most famous and impactful case is the 1815 eruption of Mount Tambora in Indonesia, which is also located on the Ring of Fire. Tambora's eruption was the largest in recorded history, a colossal event that ejected an estimated 150 cubic kilometers of ash and rock into the atmosphere. The explosion was heard more than 1,600 miles away, and the immediate effects killed tens of thousands of people. But the true legacy of Tambora was its global impact. The massive amount of sulfur dioxide it injected into the stratosphere created a volcanic aerosol veil that spread around the world. The following year, 1816, became known in the Northern Hemisphere as the year without a summer. Global temperatures dropped by an average of about 1 degree Celsius, but the regional effects were far more extreme. New England experienced heavy snow and killing frosts in June. Europe was plagued by relentless cold rains that caused crops to fail and rivers to flood. The price of grain skyrocketed, leading to food riots, famine, and disease across the continent. Other historical eruptions provide further context. The 1883 eruption of Krakatoa, also in Indonesia, was another powerful event. While smaller than Tambora, it was still mighty enough to create an explosion heard thousands of miles away and generate tsunamis that killed over 36,000 people. Its atmospheric effects were also significant, causing spectacular, brightly colored sunsets around the world for several years and a noticeable drop in global temperatures. More recently, The 1991 eruption of Mount Pinatubo in the Philippines cooled the planet by about 0.5 degrees Celsius for 2 to 3 years, temporarily masking the effects of man-made global warming. Even the 2022 eruption of Hunga Tonga Hunga Ha'apai, an underwater volcano, showed us something new. While it didn't release as much cooling sulfur, it blasted an unprecedented amount of water vapor, a greenhouse gas, into the stratosphere, which scientists are still studying for its potential warming effects. These historical examples are our benchmarks. They are a stark warning. If a single eruption like Tambora could cause a year without a summer and widespread famine, it is chilling to contemplate what hundreds of such eruptions happening at once would do to our planet and our civilization. It gives a terrifying credibility to our nightmare scenario. After exploring such a terrifying, world-ending scenario, it is time to step back into the realm of scientific reality. It is absolutely crucial to state this clearly. The simultaneous eruption of every volcano on the Ring of Fire is considered scientifically impossible. While it makes for a dramatic story, the geological mechanisms required for such a synchronized global event simply do not exist. The Ring of Fire is not a single, interconnected system like a string of firecrackers with one long fuse. It is a collection of many different, largely independent volcanic systems and plate boundaries. The volcanoes along the ring are separated by vast distances and are driven by distinct geological conditions. A process happening at the subduction zone off the coast of Chile has no direct or immediate influence on the magma chamber beneath Mount Fuji in Japan, thousands of miles away. While a massive earthquake can, as we discussed, potentially trigger a nearby primed volcano, its influence diminishes rapidly with distance. The energy from even the largest conceivable earthquake would not be sufficient to cross entire oceans and continents to activate hundreds of separate, stable magma systems all at once. Each volcano operates on its own geological timetable. The Earth's systems have built-in checks and balances that make such a cascade event vanishingly improbable. Volcanism is a way for the planet to release its internal heat and pressure gradually over millions of years, not all at once in a single catastrophic burst. The likelihood of hundreds of volcanoes all reaching their critical eruptive state at the exact same moment is statistically zero. It would be like flipping a coin 1,000 times and having it land on heads every single time. The planet is a complex, dynamic system, but it is not a fragile one, poised on the brink of total self-destruction. So, while we must respect the power of nature and prepare for the very real threats of individual earthquakes and volcanic eruptions, we should not live in fear of a global Ring of Fire apocalypse. Such events belong in a world of fiction, not fact. The Earth is a restless planet, and disasters will continue to happen. But they will be regional, not global in this manner. Our world is not going to end in a worldwide volcanic firestorm. The ground beneath us is far more stable than our worst fears might suggest, and for that, we can all be profoundly grateful. We are safe from this particular doomsday.